Hello, everybody, and welcome to the Microsoft Data and AI South Florida user group. My name is Adriano, your host. And today, I thank you for making the time to be here with us. And as we are starting, let me know on the live chat, where are you located? And as you can see, I am located in sunny South Florida. And today we have some, let's take a look at here. Remember, uh, this is the type of content you like. Click the like, subscribe, and remember to click the bell so you are notified when new videos are made available. And at the end of this presentation, something very special for you, which is the book raffle for the Azure Synapse Analytics cookbook. Thank you, Packet, for making it available for us. It's right on topic here. And this is all part of the Microsoft Data and AI South Florida user group 10 years celebration. Yes, August marks our 10th year in operation. And thanks to all those who came before myself to make it all possible. Let's take a look. Without further ado, I bring you Dustin, and he's going to be talking about data ingestion with Azure Synapse Analytics. And welcome, Dustin.
Hey, thank you, Adriano. Good to be here.
Pleasure to have you here. Really appreciate your sessions, and we are honored to be able to learn some more because you have been here in the past about some great synapse.
Yeah, looking forward to some fresh content for you here.
Excellent. So, can you tell a little bit about you? Where are you located at?
So I'm here in sunny San Diego, a little bit earlier in the day, so definitely sunny still. And I'm a data engineer, which I'll talk about a bit as we go along today. Yeah, anything else you want to know?
Just a second. Let's take a look here where some of the attendees are located at. And hi, folk. We have Dennis. Thanks, Dennis, for joining us again on the exciting Azure Synapse presentation. And we have, pardon me, Kriba, I hope I pronounced it correctly, in Aurora, Illinois. And wow, Niraj from Sydney. And Dennis from Montreal, though he lives also in Fort Lauderdale. Yes, from the neighborhood, Dennis. And what the heck? Yes, Hector. He's also, I know him very well. He's from just the neighborhood as well, just down the street. Thanks for joining us. Yep, he's in Miami. There we go. And Niraj, Australia. All right. You see, from different parts here joining us today. Very exciting. Folks, remember, if you have not done so, I will drop a link here in the comment for you to sign up for the book raffle. And 30 minutes before the end, we will just, take the person out, the names, and after the presentation, we will do the book drawing. And today we have 2 books. All right. So remember, without further ado, it's all you, Dustin. Thank you very much.
All right. Well, thank you again. And thanks everyone for joining. So we'll be talking about data ingestion with Azure Synapse. And the focus of this is really real life scenarios and solutions. So I've taken some of the things I encounter in the real world and tried to focus the talk around decisions that we make within, if we're focused on using Azure Synapse to solve the problem, some decisions we make about which tool to use for data ingestion, kind of the initial stages of building that data lake, building your data pipelines. Okay. So quick intro is that I'm Dustin Vannoy, and really my contact info is here, but it's also in meetups. You can go find it there as well. You can find me on YouTube for more demos and stuff. But I want to share that I have a data engineering San Diego meetup, which is also virtual. We may go hybrid, but we'll make sure we have some online content for you. So no matter where you're at, if you want to join us sometimes as well, find us on meetup.com or follow me on LinkedIn, and I'll post when things are coming up. Other than that, let's make sure we know what we're talking about in this session so that you know whether you want to stick around or not. So we'll be talking about data ingestion. I'm going to define that for you. Make sure we're kind of on the same page. That'll be pretty quick though. I do a little bit of a technology overview for Azure Synapse. There's been a lot of great sessions with this meetup alone about Azure Synapse. So I'm going to assume a bit of knowledge, but if you don't have any knowledge on Synapse, it's okay. We're going to try and get you up to speed at a high level. And then I'm going to talk about it and show it all throughout the rest of the session as I go through 3 different scenarios for you. Okay. So what is data ingestion? This is my definition of data ingestion. The top line is kind of the most important piece, which is it's the process of bringing data into a data lake or a data warehouse. We'll talk more about that next. So it's a process of bringing that data in, not necessarily the full end-to-end. However, data ingestion often does include cleaning, enriching, and transforming the data. So depending on who you talk to, which organization you're at, they may really focus in on just that initial pull the data in. They may focus on a lot of the processing along the way. Usually the ingestion talk doesn't involve the final like ready to go layer. And so we'll talk about that, but not really show it or go all the way with the pipelines I demo today. So I talked about data lake or data warehouse. Let me give my quick definition here of a data lake. So a data lake is a platform that's big data capable. So it's something that you build with, usually with the idea of storing the data first, possibly without schemas around it, and then evaluating and modeling it later. So you're going to lean towards storing a lot of data, bringing a lot of data in, even if you're not entirely sure which columns are needed, how it'll be used in the future. Another thing about a data lake that's important to know is that we do organize it a bit. And so typically there's about 3 different levels, maybe 4, but usually about 3 different levels or data zones. So raw is kind of the thing we'll focus on the most today, that initial landing of data in a very unclean or not cleaned up, not transformed state. So we can have something that looks very similar to the source systems that we're pulling it from. And then enriched, there's different names for it. Enriched is where we start to clean it up a little bit. You might start joining some data in or doing lookups, things like that to make the data just a little more valuable. You still might keep the enriched zone fairly hands off for most users. Only like your super users go in there. It's kind of depends on how well you're going to take care of that enriched zone as far as how you decide that. And then finally, the curated or certified zone. If you know the Databricks medallion architecture, they talk about bronze, silver, gold. The curated is your gold level. This is like the high quality stuff that if someone's building a report to send to the CEO, to send public, then they're going to be in this like certified area where we know that we've vetted, put data quality around, and have eyes on the data regularly. And we can make sure that we can bring reports to the meetings that actually look like similar numbers and aren't coming from completely different systems without any sort of integration in any way to reconcile them as you're in that meeting. So that's the idea of curated certified. You have ready to go data sets and you can get accurate results out of it without leading to a lot of confusion. The raw layer, the reason the raw zone is for super users is because you can do all sorts of things with the data. It's still in a really raw format. And usually the numbers end up being different depending on decisions you make along the way. Okay, so that's part of data lake. That also kind of applies to data warehouse, but we'll focus on it for a data lake here. And then a data lake should be ready for analysts. It doesn't matter too much for the focus of this talk today, but just a heads up that data lakes aren't usually just a big old storage system you throw stuff into. They also, there's an idea of connecting different query tools to it. You may be connecting things like Power BI or Tableau. You may be connecting Spark, which I'll show you today. You may be connecting Excel even to this data lake. And so you know that people will bring their own tools and some kind of access and ability to connect will have to be determined for it to be valuable. And so that's a piece of the data lake itself, is that ability to connect. Okay, on the data warehouse side of things, data warehouse is probably going to be structured data. Usually when we're talking data warehouse, we've processed and modeled the data and it's ready for analytics use. We've made some decisions along the way. We might have filtered out some data that's not very, very helpful. We might have reduced the number of columns. We've probably optimized it for certain types of reads, things like that. We're expecting interactive queries on a data warehouse, which basically just means the time you sit there and wait for the results of your query or for your report that you built on the data warehouse to show up, you're expecting that to be, I don't know, a few seconds, maybe 30 seconds or so. For certain use cases, you might be looking for second queries off your data warehouse. When you talk about a data lake, you might wait a minute or two. It can be a little bit longer. However, there is a lot of effort to make that data lake wait time even less and get these things closer and closer together. And then finally, this will definitely have BI tool support. You usually have some kind of enterprise tool that you're expecting people to use, like Power BI. But then again, you may allow them to connect with a bunch of different tools as well. It kind of just depends. But as we look at Synapse, there's going to be things that are meant for you to write SQL against, like dedicated SQL pools, and you're going to expect that to be your data warehouse workload. Whereas serverless SQL lets you write SQL against a data lake. And so when I talk about data lake or data warehouse, that's a big difference. Is it on a file system that's ready for analysis, or is it actually into some kind of database that's meant for these fast queries and support? And if you're wondering what data lakehouse is, it's kind of trying to do all of that on the data lake, which means you're bringing more of those data warehouse concepts into the data lake as well. Okay, so when we talk data ingestion, this is my hierarchy of data ingestion. It's inspired by some different hierarchy of data needs that I worked on with some coworkers when I was at Pluralsight. And so we've got this bottom layer. The most fundamental need for data ingestion, or for data pipelines really, is to collect that data. You pull it from different source systems. It's almost never in a single spot. You usually have to do some hard work to get it together into one location. We make that data available because if you collect it and lock it down so securely that no one can touch it, you lose a lot of the value there. Then we're going to clean and enrich that data, which happens in that enriched zone that I talked about. And then finally, you curate it and have it ready for reports. So today we'll touch a little bit on the enriched, but we're mostly down in those bottom three: the collect, make available, and clean area. That's what we're talking about. We're talking about data ingestion. And then you'll have to sort of dream up what the transformations and enrichment might look like for your following steps after what I covered today. So I'm not going to touch much on these, but I do want to call out that there's decisions you have to make. And I'm going to be trying to address some of these decisions as I show you each scenario. So we're going to have to make decisions on, do I have a kind of low code graphical tool like Data Factory or Synapse Pipelines in my data pipeline ecosystem? I guess on the other hand, you also need to decide, do I have a more code first solution like Spark or maybe Pandas or other scenarios where you're writing a lot of code rather than doing the graphical interface thing? You need to decide how we're going to monitor job success. I'll show you a little bit about how we do that in my first example, especially. You need to think about, how do we validate data quality? At a minimum, you at some point will finish the project, go to production, and then the question is going to come up, if it doesn't happen sooner, of how do we know this data is accurate? What happens when it fails to load some of the records? How do we know this? And you can build that on at the end, and it's not a terrible approach as long as you put the time in when it's time to go to production. Or you could build it throughout the pipelines, which is a great way to go, but it adds to the time it takes to get your pipelines ready for production. And then we have to think about things like encryption and security. I don't address this a lot in my sessions, but I just always want to remind you that if you're working on building data pipelines, you should be just checking on that someone has been reviewing this as far as making sure that confidential information is being kept private. We're doing the right things to make sure that we don't expose our customer data or expose our company in any way, right? So always think about that. And if there's strong encryption needs, that can change which tools you use and which data storage systems you use. So with that, let's do my quick overview of Synapse to try and make sure we're all kind of in the same boat as we start the rest of the session. Before Synapse, I guess I want to call out that Azure Data Lake Storage Gen 2, which we normally just call ADLS at this point, is what we'll probably use for building a data lake in Azure. And so all of my scenarios include Azure Data Lake Storage as kind of the fundamental place I'm trying to store the data. When I ingest it, I'm trying to keep it somewhere in Data Lake Storage, either that raw, enriched, or curated, probably a storage container within Data Lake Storage. And so this is meant for analytics, is really the thing I want you to know. It's also relatively low cost to store a lot of data on Data Lake Storage. The numbers will add up, especially if you're just getting started and not doing a lot of processing, but you can store a lot of data for a long time here. And for most companies, it's not going to be the concerning part of the budget, I guess, is the way to think about it. Now, Synapse Analytics is a pretty big platform that Microsoft has given us within Azure to do analytics. And so I'm going to call out the main things I think you're going to use Synapse Analytics for potentially. Managed Apache Spark is one that I really like, and I use that within Synapse quite a bit. I'll keep talking about that. Synapse Pipelines, like I already addressed earlier, is something that you can either use Azure Data Factory outside of it or use a pretty much equivalent version Synapse Pipelines within Synapse. But it also brings together this way of querying your data lake storage from serverless SQL, basically write queries that look like T-SQL and hit that storage, or having dedicated SQL, you've got yourself ready for massive queries, partitioning a lot of data and having it structured and ready to go with good indexing there. And then Data Explorer is this thing that's come along a little more recently, and it's really a way to deal with log analytics and telemetry. If you have massive amounts of data coming in, I think you want it to be immutable, if I understand correctly. You can use the KQL language to explore that and search that. Just kind of another summary, more for you to read it if you need to see it. Sometimes I gotta see things on the screen, but where I'm going to use Apache Spark is typically data processing and exploration. And where I'm going to use Synapse Pipelines is for data ingestion or data processing, or for orchestration. We'll talk about the difference there as we go. Serverless SQL is really for easy querying of data in my data lake. You really could build up a system where serverless SQL is the main way you query the data. You could have Power BI running serverless SQL queries to get that data out. It's not a bad idea. You're definitely going to look to it for a way to quickly query the data lake data, do exploration without having the extra cost of storing it in another place and optimizing it. When it comes to get dedicated SQL, that's where it's worth the money. You've probably got over a terabyte of data. You've probably got some decently large data sets here. You're going to structure that data and model it. You're going to decide how to partition that data so it's good for parallel processing. A lot of concepts I'm not trying to teach you right now, but just to say that there's a little bit different way of thinking about dedicated SQL, but it's also going to give you a little bit more of the feel you would expect of SQL Server. Serverless SQL is going to let you write code that looks like SQL Server, but it's going to run quite a bit differently because it's file storage under the covers. Okay, so let's get into scenario one, which is ingest from Azure Storage. I guess before I keep going on this, do we have any questions yet, Adriano? All right, we'll keep going. After the demo, I'll take a little break and we'll address any questions you all have.
No,
all right, so
I do not
with
see
data
any
lake
chat.
ingestion.
Oh,
Yes.
Sorry. So folks, remember, just use the live chat, enter your questions, and we'll follow up. It's always
Okay. All right. So as we talk about, this scenario is ingesting data from Azure Storage. So some way, maybe someone's dropped the data for us. It's already in our data lake storage or blob storage within Azure. And so we've got kind of an easy one here, especially for the demo I have. I've kept it in a format that's pretty easy to query, to work with all the tools that we have within Synapse, really. But here's the idea. So whether it's in data lake storage or it's in some other source system, one option I have is Synapse Spark. The benefits of Synapse Spark, in my opinion, at a very high level, are that I can write reusable code libraries and I can use those over and over again in different jobs. And so if it's a simple solution that's moving from a distributed file system to another distributed file system, something I can query in parallel, and I'm able to access from Synapse Spark, I like to go to Synapse Spark personally. And I'll show you a little bit about how I do that to try and make it very reusable, consistent in how I work with it, and something where I don't have to think too much about each new process that I add to the mix. When we're working with it, though, I want you to know, and you'll kind of see it, but this is to make sure it's clear. We're going to be writing data to Azure Data Lake Storage into the raw zone. We're probably going to be reading it back in and then doing additional processing, maybe joining to other data sets, and then writing to enriched, and potentially would keep on going, right? And do more processing with Synapse Spark. Maybe you'd go to serverless SQL or something then, but you might just keep using Spark for the whole thing and write the final data set to Data Lake Storage. So there's a lot of back and forth between Spark and Azure Data Lake Storage to build out the different useful data sets you have. Okay, so why do we use Spark? I give you my quick version, or why does Spark exist actually is what this slide's about. And so here's the short version. We hit this point in history where some companies had a large amount of data and trying to buy really big beefy servers that were usually a combination of like software that's really meant to work with specialized hardware started to become expensive and not the way they wanted to go. And they came up with this idea of MapReduce as a programming concept, and Hadoop was the big product or open source platform that came out, which was basically, let's store the data across all these less expensive servers, take a bunch of servers, put them together, store the data across it, and write programs that can make use of the fact that we've got all these different computers working together. Spark was a way to use memory better, run those MapReduce jobs, write those MapReduce jobs easier, and run them faster than you could with the MapReduce that came out of Hadoop 1.0. And so with Spark, we've got this fast general purpose data processing tool. There's a lot of good options for data processing. Spark is really general purpose, which is what I like about it the most.
Sorry, Dustin.
Yes.
You're supposed to be sharing something.
Are you seeing my slides?
No, I do not.
Oh.
Remember, you pulled out and then, oh, yeah.
All right.
This
Are you
is
seeing
the
the
things
screen
at the
now?
bottom. Yeah, nope. Stand by for a second. There it comes. All right. Here we are.
Okay. Oh, I think I know what it was. Okay. You can still see it, right?
Yes,
Here we
I
go.
do see it now. It says Y Spark.
All right. Okay. Let me finish what I was saying there. So it's a
Sorry.
fast general purpose way to process data. It is a way to do simple programming and get distributed processing. And it gives us a bunch of options to run it. We can run it on top of a Hadoop ecosystem. We can run it in Azure with Databricks, with Azure Synapse. We can run it on quite a few other tools that I don't hear about as much. You can run it on Kubernetes if you want to take open source Spark and deploy it yourself. There's a lot of options there, which is nice because as you bounce around different platforms, you can take the same concepts and programming framework that you used to and use it in each platform you work in. So for those that are brand new to Spark or the idea of this big data stuff, here's just one second on what's going on. We're going to submit an application to a controller node. It's called the driver application when you're working with Spark. And that's going to take as much of the work as it can and send it out to the different workers to do on their own. And then it's going to pull back the results of that and then put it together to give you your final result. That's basically the idea. If I can read in parallel, it's going to do the reading from the worker. So it'll send off different chunks to read from each worker. If I can write in parallel, it's going to try and write from the workers. And so with distributed storage, like Azure Data Lake Storage, it can read and write from the workers, and it may not really need to even pull back to the controller if you can write your code carefully and just keep in mind the fact that anytime you start to sort and things that cause your data need to come together and know what the other workers have, that's just going to slow it down a little bit, but that's okay. That's more advanced topic as you get going. Ultimately, what we're doing is using these worker nodes as much as we can and try not to have to shuffle the data around the cluster. And that's how we get good performance out of Spark. Okay, so let's jump into the demo here and take a look at ingesting Azure Storage. There we go. Okay, so hopefully my session's still going. It says it is, but you never know. I'm in Azure Synapse Workspace. If it's your first time seeing it, basically what you need to know is you come in and you go to the develop section to get to your notebooks, and then you can create a new one or start with one you've already got. So I've written this Stack Overflow data ingestion. Like I said, I'm going to read from Data Lake Storage and write back to it. So here's my steps. I can add Markdown pretty easily within Synapse notebooks. Basically, when I create a cell, it gives me the Markdown option. And you can see there's nothing too fancy going on here, but it makes it a lot more readable than comments in my code. So if I'm building my production code in notebooks, I would recommend having some sort of Markdown cell at the top that says what this notebook does. That'll save people a lot of time searching through code, trying to find the right script for what they're looking for. Basically with this one, you can see we're going to read the data from the external data lake path. We're going to save it as Parquet in our raw database, our Spark database, which can also be queried from Serverless SQL. And then we would do additional transformation and enrichment and save it to our refined database. It can vary on which format you choose. I'm going to use Parquet for raw, and I'm going to often go to Delta for my refined layer, but that can vary depending on how you plan to query the data. So the first thing we see is a cell that we'll go ahead and run it as we go, except for the long running ones. So we're just going to import some things from Spark SQL functions. And we're working with PySpark here. Somewhere in here, they've got a little option you can't see because I'm zoomed in, which says which language do you want to use. So I can pick Spark SQL, I can pick Scala, I can pick C# if I choose to. We're setting some paths. That way I don't have to think about where my data lake paths are. You could also get these from Key Vault if you want to control those across environments that way. And then this is how I'm going to build reusable code using only notebooks within Synapse Spark. I can run a notebook with %run. So I've got this logging utils that just defines a bunch of functions that I use for logging. I think it even initiates a variable since it's going to run as its own block of code here. So I run this, and now I've got some logging functions available that I can use in every one of my notebooks that I write. Why are we doing this? Remember, I said we need to think about monitoring. How am I going to, once this is running live, tell people whether or not it worked and maybe do some reports on it? We need to get that data somewhere. So we log it. We can actually set up our Spark pools and Synapse to write to log analytics and build reports off of log analytics to really see kind of an end-to-end across the platform view of what's happening with our data pipelines. Okay, so here's where we won't spend time talking about how exactly it works, but these are initializing variables and setting up my logging with start logging. So now I've got this variable called logger that I can use throughout this to add additional log messages. All right. This is for people who already know Spark and want to get an idea of what we're about to do. What we're about to do is essentially reading a file from Spark. So with Spark, you would do spark.read.parquet as the format here. And I give it a path, and it's going to try and read in all the files in this directory within Data Lake Storage. Once it's done with that, it's set it to a variable called df. df stands for data frame because that's our main object we work with in Apache Spark. Then I can do save as table to save a brand new Spark table within my Metastore that I'm connected to. What that means is I'm going to save, I've already created this database by this point. I'm going to save a table called badges under a database called Stack Overflow. It's actually going to save it to the file system, but it's also available to query as SQL as much as I want to. So that's basically what we're doing. However, I don't want to write those commands for each one. And I also want to be able to have a little bit of reusability and probably at some point some error handling built into what I'm doing. Therefore, I'm going to build it out as functions, right? So we're getting away from here's an intro to how to use Spark to here's how to write code that I can actually maintain and build a big data platform out of without copying and pasting stuff everywhere and ending up having a lot of trouble when it's time to change that in the future. Okay, so the first one I have is get table paths, and I try to give more documentation than code so it's easy to understand. Basically, we're going to pass in a path to data, and it's going to return all of this directories there, which is how I know that I have data to process. You'll see that at work just at the bottom here. Eventually, we're going to save the data. And so to save the data, same concept I used of saving table, give us a few options to work with, pass in a data frame, pass in a table name, set up partitioning if we need to, set up a format if we want Delta versus Parquet. And basically what happens is we translate that data frame right that I talked about earlier to a little bit more generic Spark code with a few more options that I didn't call out in my first thing. So we can do overwrite mode. I think I've defaulted to overwrite mode everywhere here. And we can add partition and things like that. So we take some Spark code that's pretty simple, add just a little bit of wrappers around it so we can reuse it. That could also go into a notebook that I run as a utility, kind of like I do with my logging, rather than having it directly in the code that's going to run my pipeline. That way I can reuse it across many notebooks. All right, so we're down here to a cell where I'm going to actually create the database if it doesn't exist. I'm going to get all my tables and I'm going to print that path. We'll go ahead and run that because that's a quick one. So this is how you can see the result of that table get table paths function. So it shows me this is a folder name, this is a folder name. Each of these folders, badges, comments, post links represents different tables, so to speak, within the Stack Overflow data that's available in this other blob storage that's kind of outside of my Synapse environment, but I've got permission set up for. And then the full path is also here because I'm going to need the full path when I go read that data. So it's kind of a full path and then table name is what we get back. So now what I can do, since I'm using Spark, I can easily loop through that list of tables and submit separate jobs for each one using those special functions I created earlier. So for each table that I've got, read it into a data frame. And I didn't bother making the read anything special because there's not a lot happening on the read in this case. And then I call my save table function, pass it the correct values, and that's going to write each table as files in my data lake and give me access to them through the Metastore. And then, of course, I talked about logging. I've got a special function for logging to make sure that I'm keeping track of which tables have completed processing. I got a little bit of extra metadata I store there. I don't think I'm going to spend time looking at the logs today, but Tracking a little bit like how long does it take to run each step, or at least potentially I'm tracking that here. Most importantly though, if it breaks, I can go see which table processed last. And you can see this took about 12 minutes to run. I'm on a two worker cluster, small as you can go. Ultimately, the reason it took that long though, is because I have one big table. If I expand kind of the monitoring that's built into notebooks, I have one big table. This one, actually, I guess two, kind of. Three maybe. And each of these took a little bit of time, and Spark can run in parallel, right? We've got this big cluster. It happened to run these one after the other. And so if 12 minutes is not fast enough for me, there's something I've got a YouTube video on. I won't show you how to do it right now, but I could actually use Python threading to submit multiple of these at once. Or the next thing I show you is Synapse Pipelines also is another way to run a bunch of these in parallel, not just do one table after the other distributed across Spark. Okay, so here's the point. I've got reusable code. I've got logging. I can loop through a list of tables. I could point this at another data set, loop through that list of tables. I have a few things hard-coded that I can make variables that I pass in. And we can now do a lot of our initial ingestion with Spark without having to stop and think about what is the schema of the file or the table. And some of these things that become important at some point in your processing, but you don't want to deal with them in this raw ingestion. You want to deal with those later down the line when you're getting close to building reports. All right. And then one more set of steps just so that you're aware of them. I use the same kind of functionality to create my refined database if it doesn't exist. I get a list of paths that I just created in my raw section of Stack Overflow. I didn't bother printing those out because it basically looks the same as just in the refined container instead of the raw container at this point. Next, I'm going to use very similar code. I start to do just a hint of transformation here. df.withColumn is in Spark a way to add columns and add columns based on functions or other logic you put into it. So I'm going to add a function called refresh date. And I'm just going to use this basic SQL function called current timestamp that's available in Spark. You could do quite a bit more here, but that's just kind of a quick glimpse at how you'd start to build in your transformations here. Or you might break that out as its own notebook. If there's a lot of really specific Stack Overflow stuff there, you might have a generic read it to raw notebook you use, and then have a complex refined one to really start to get specific with the data set. And then I use that same save table function. Sorry for the clicks. Save table function. I save it as delta this time just because I'm expecting in the future I do upserts with it instead of just a flat overwrite. And with delta, I have the ability to do what's called a delta merge and really do like an upsert to that table and avoid having to rewrite the whole table every time. Realistically, for performance reasons, I'd probably end up with one or two tables that I do a delta merge with because I don't want to rewrite the whole thing, and I may not even read all the data off the source system each day. I'll read just a portion of it. But then for a lot of the small stuff, to make sure I handle deletes easily and keep my code simple, I just do an overwrite of it. It'll only take a minute or two for most of these data sets, and it won't really slow down my ETL jobs, my data pipelines. Of course, we're going to have logging happen. Oh, I did break something today. Look at that. Something's got to break in a demo, I think. So it's trying to infer the schema, and for some reason it's having trouble today. I'm pretty sure I've done it before, so I'm not sure what's up with that today. Finally, at the end, I'm going to stop the logging, which is going to do some calculations and just make sure that I've got something in my job that in my logs that says, hey, you did it. You got the Stack Overflow ingestion from ADLS done. We're going to move on to the next step of the data pipeline. So with that, I'll move on to the next section of demo and next scenario here. But if there's any questions on this piece, now's a good time to take one or two of those questions. So feel free to chime in with those. All right.
Hello, everybody. Remember, enter your question here in the live chat. Just looking out. We have no questions at this point, and it's all you there. Thank you.
Okay. Okay, so the next scenario, and I'll mostly show this. I'll show as much as I can just to make sure we don't spend all day on watching it run, is ingesting from SQL Server. So I'm going to kind of pretend this is a little more complicated case than it really is. Let's talk about what comes into my decision making when ingesting from SQL Server rather than data lake storage. So The first thing really with any database is I don't want to have to change the schema, the table schema. I don't want to change data types of columns. I don't want to lose the good structure I've got if I can avoid it. And so we're going to try and make sure along the way that we keep that. And you can do that with Spark or with Synapse Pipelines, which are kind of the two options I'm focused on when I'm in Synapse. But it's something you want to keep in mind about how you build it to make sure you don't lose track of that structure, because it's pretty useful. Unless for some reason you need to go blend it with a bunch of data that has no structure, then it becomes less important, right? So you want to think about, how will I maintain this as new tables get added? Very important thing to think about. How do we expand this in the future? I built some systems that worked really well for data pipelines, but they didn't work very well when a column name changed or a column needed to be removed. They kind of broke down quite a bit there. At some point, it becomes an issue, right? If you change an important column name, someone's got to deal with it at some point, but you don't want it to happen on that raw ingestion step of your data processing. That's the main point to get out of that. How will I deal with new or removed columns is something to think about in line with what I'm just saying. How do I do, or should I do a full reload of every table for every run? It's definitely simpler code if I do that. It often performs pretty well if you've got something like Spark or Synapse Pipelines and you got a little bit of processing power you can use. Usually, though, there's some really large tables where that becomes an issue, and you may have to do the work for change data capture, delta load type of scenarios. Is it inside of our Azure virtual network or something we can easily connect to with private endpoints? If so, we have lots of options to do it within Azure. If not, we start to have to do some other things. Why don't I talk about that in the demo space here and call out what I mean there? And then, do we need to add specific IPs to an allow list? Is there some kind of, whether it's a SQL server that you maintain, maybe it's off premises and someone's got it open to the public cloud, but they've got a list of who's allowed to access it. We're not going to be able to easily say, hey, if I've got this Synapse environment on a managed VNet, we're not going to easily give it IP addresses to add to their allow list. And so we may have to do some stuff different because of that. Right. So it can be really simple, but as we start to look at the real world use cases, it tends to get a little bit more complex. All right. So let's jump back and look at this live from Synapse instead of from slides. Here's the scenario that led me to bail on Spark for a use case and instead use Synapse Pipelines. So the SQL Server environment was not in Azure. I could not build a private link to it. It was on, let's just say on premises, often a data center somewhere that's very disconnected from the network that I'm in. And I can't just grab the IPs of my Spark nodes that are running. I'm in this managed VNet thing. So Microsoft's doing a bunch of stuff to keep things secure, but I'm not managing the machines. I don't have the IP addresses to just plug those into an allow list over there on the SQL Server. So Synapse Pipelines and Azure Data Factory give us this nice capability of having a self-hosted integration runtime. What that means is I can actually install a virtual machine and work with it there. I'll point that out as we go. But because of that, I said, hey, let's look at how do we do as dynamic a process as we can with Synapse Pipelines. And where I found myself was using the copy data tool. I ended up with a little bit of a hybrid between the built-in copy task and the metadata driven, but I want to show the metadata driven task because that really uncovers a lot of capabilities, a lot of potential for dynamic processing within Synapse Pipelines. So what this means when I go metadata driven copy task is I'm going to store some information about which tables I'm processing and how I want to process them somewhere. Typically, you're going to pick some kind of database. So I'm going to pick my serverless SQL box. I think it's going to connect smoothly here. We'll find out. You may want to give it a better name. We'll stick with the default though, because it's just a demo. Let's make sure we have connectivity before I waste your time going to the next step. Hey, look at that. So this is not where I'm putting the data. It's not where I'm pulling the data from. This is storing information about the process, the list of tables I'm going to process. Okay. For now, we'll just say run it once. Don't need to schedule it yet. Okay. So with this wizard, we're going to pick what data source we want. And so when you define a new connection, if it's a SQL Server environment, I can search for SQL Server, grab that UI, and in it, I'll give it a good name, of course, but I will need to define the correct host information, define the correct database. But this piece here is what I wanted to call out for you. This auto-resolve integration runtime is going to be running within the Azure environment, and I don't have as much control over it. Especially if I'm working with managed VNets and I'm going outside of Azure, I might find that it's way better for me to create a self-hosted integration runtime. The short version of that, there it is. Sorry about that. The short version of that is when I click this, I do self-hosted, create a new runtime. It's going to walk me through the steps. Basically, I'd go set up a virtual machine or a machine on premises if that's going to be the fastest way to get the data. I'm going to install the software and then I connect it to my environment. So that's one reason you may end up working with Synapse Pipelines, even if you really like Spark like I do, is in order to be able to use that self-hosted runtime. You can do some port forwarding, and I have had someone set that up for me, so we've been able to do that. But that's not something, if I was just a team of data engineers, we probably wouldn't spend the time on that ourselves. It's a little bit out of our skill set, basically. Okay, so from here, if I'm doing Azure SQL Database, which I happen to have one of those to make it a little bit easier, I can go click the drop downs, find what I need. Often I'm going to really, not often, but sometimes I need to loop through multiple databases that have the same structure, or maybe switch database and switch control table, but I only want one set of code to deal with. And if you're going to do that, there's other demos that'll tell you more about how, but you can add these little parameters like database name and make this thing really dynamic if you choose to. So with that, I'm going to come back here and pick one that I already created so I don't click the wrong buttons and get stuck with it. Once you've created or selected one, it's going to give you a list of tables. I'm zoomed in a bit. Let's take the risk of zooming out just a little bit for you. So there's multiple tables here. I picked the wrong one. Hang on now. The one with Stack Overflow in the name. That's the way to go. Okay. Refresh my list and we're going to see, I think I clicked the right button there. We're going to see a list of tables that are Stack Overflow data, badges, comments, a few random things I pulled in there that I don't actually need. I'm pretty much going to select everything, remove the test tables that I started putting in that database. And then the next piece is, do I want to do a full load for everything, or do I want to do what's called a delta load, an incremental load for some of this? Since I need to do an incremental load for my post table, I would do configure individual, grab post. I won't go too deep on any of these, but basically you set up a watermark column. A lot of times a date's a good way to go. What I'm going to try and say is from the last time I loaded it, anything that's new will have a date that's, later, that's higher than the last time I loaded. And so it's going to store in my control database, that I ran it on August 2022 at a certain time. And then it's going to find everything created after that each time it runs. And that'll keep us from having to reload of all the data every time if it doesn't change. I can give it a start date. I guess I have to give it a start date. I'd go back to probably go way back in history, but for this, let's just do that since I'm not actually going to run this version of it anyway. We have some advanced options like partitioning. If you've worked with Synapse Pipelines, you're probably familiar with this. If you're not, and it starts to run slow, you're not getting good performance reading off your table, go look at partitioning and dig a little deeper in that. I often don't have to start with partitioning, but there's usually a table or two where it becomes important and we do it this way, or there's a couple other ways to set that up. Okay, so after all that, hopefully I've checked all the boxes that are required. I'll jump to the next step. And here we're just configuring our destination. So I've told you that I'm doing ingestion to a data lake. Therefore, I'm looking for the right data lake storage link service. And so I've got one set up as a link service already. My managed identity within Synapse can connect to it. So that's definitely the way I would recommend connecting to your data lake storage whenever possible. Because it's in Azure, because I've got this link service set up, my auto-resolve runtime will work for it. I don't have to do any self-hosted stuff. And then I'm going to specify the path within the storage that I need to write to. And I think it'll let me browse, right? Okay, so I'm writing to raw, writing to my Stack Overflow SQL history. I didn't really bake out the scenario a lot, but basically the idea here is that I've got my history data is all in SQL Server. My new data is all over in data lake storage. And that's why you might have both of these in the same project. I bring up that scenario because that really is the scenario I've dealt with the most often, is that we've got SQL Server That's where some legacy processings happen. And we're going to start merging in this new stuff with that legacy job. All right, with that, we need to decide how to save it. I would be saving it as Parquet because I save all my raw data as Parquet in this environment. On the next page, I get to actually choose the type, make sure I like the compression. Snappy is a great one to use there. Give it a good name, set up concurrency. So a lot of times you're going to have some amount of concurrent task running. 4 is a little bit small probably. If we're going to go through all the trouble of running this type of system, we probably want more than 4 tables at a time. However, that's okay because I'm paying for this one, so I'll keep it small. I'm going to set up data integration units. It tells you right here how much you're going to be charged for that. It's an element of processing power within Synapse Pipelines. And then copy parallelism, we'll set that to 4. So that's my quick, don't really think about it settings that I do. I don't leave them default usually because I don't want it to go crazy and cost me a lot of money. In a real environment though, it should do a pretty good job with the automatic settings, but do pay attention to them. Finally, we've got our timeout is 7 days. So you would really want to change that, but that's okay. This is a test. I'm not actually going to run this thing. And now it's going to go through the process. Maybe I should hit that button. It's going to go through a process of creating the control database scripts I need to run, setting up these pipelines, generating this stuff for me. So you may know, if you've been around this industry a bit, you may know that when a system generates the code for you, it's not always going to be exactly how you'd want it, but it did generate it for you and saved you a lot of time. So what I usually do is I go and I do some tweaks and modify some things, but you don't have to. You could just learn this syntax a bit better and work with this going forward. Really the thing to take away, I'm not going to copy it over and spend our time on that today, but the thing to take away is that it's got a JSON element per table. So if you look a little closely, you'll see there's this badges table. It's going to save to a file that's named badges. This whole block of information is about how we're going to process the badges data from SQL Server. If we go to the next one, we're going to see a different table name. So what that means is if I need to add a table, I've got this control table somewhere. If I have a new source table to add, like, I don't know, Stack Overflow, like score or something, I can go and just grab one of these blocks of JSON and go run some modified version of this script that inserts a new record with all this JSON. That's the idea here. So I would download these things. I don't think I clicked that button, but normally I download these things, then create those tables, and then I'll go and view the pipeline and start testing it out and see what's going on. I can come back and answer more questions at the end if people want to see a lot more about what gets generated there, but let me do the short version by showing you one that I ran just a little bit ago. So in this case, I did not get any errors today, which is always nice. When I trigger something like that, it's going to kick off this top level job. That top level ends up saying, how many tables do I need to process? If it's more than a certain threshold, let's spin up multiple middle levels so that we can get really good concurrency out of our system. There's only so many. Anyway, there's some limitations that you can get around by just spinning up a middle level that then spins up multiple bottom levels, basically. So it's going to control how many different things we run in parallel. In my case, we needed one top level, one middle level. Kept it fairly simple. Actually, it looks like we did too. And then what really matters, though, with that I want you to know happens, is when it calls down to that bottom level, it's going to have a list of tables to work with. Let's go into the other view to see the details there. Bottom levels there, I'm pretty sure. Let's collapse this so I can hopefully see again. It's going to have a list of items to go through, basically based on that JSON. It's going to look up my connection details. It's made those dynamic for me. And then for my simple use case, it's going to basically just have a really simple copy activity where there's a bunch of parameters that it's passing through. So what's that mean? That means my bottom level task is going to run a whole bunch of times with different parameters. That's what I've set up here. All of that's driven by a table that I can then control completely outside of this code. I tend to strip out the middle level, take a little more control of the top level, or just take the bottom level and manipulate it and just do one big list of tables. But it really depends on how much data you're moving as to whether that's better or worse than the generated one. Okay, so that's a view of like this power of dynamic pipelines. One thing I'll say about it is that when it's time to do your code reviews and things, you don't get this nice like Git view of here's all the changes that happen. You can look at the JSON and you will learn to understand it if you're going to do code reviews on data pipelines like this, Synapse Pipelines. Or you can come back to this view, walk through what they did, but you got to kind of figure out what they actually changed if it's something that already existed. So that's one of the downsides of Synapse Pipelines. It's a little bit harder to do that code change. And if you already know Spark, if you already know Python or Scala, you're suddenly learning all of these really specific things rather than using frameworks and things you already know. So with that, let's transition back to talk about streaming. Unless there's any really pressing questions, I think I'll save them for the end, unless there's something you think that should be addressed now, Adriano.
Yeah. Why would I insert to a data lake from SQL Server? Would I not use SQL Database, manage instance of SQL Database?
Right. So if you're trying to just migrate SQL Server to the cloud, there's a good chance you would use Managed Instance or one of the other flavors of Azure SQL to keep that SQL Server going. If what I'm trying to do is get all of my data across quite a few systems, typically into one place that can be used for analytics, then I want to get it all into the same format in my data lake where I can join it together. So if you think about a time where you have some really useful data that you want to join to what's in SQL Server in order to get some new, some new analytic insights out of it. What you end up having to do is go and like ingest that to your production SQL Server, deal with modeling that data and things that may or may not be hard for you, but you have to do a bunch of steps to get it into SQL Server. What we're really trying to do is say, let SQL Server do what it's there for, but get that data out and into an environment where with all this other data that may not have as much structure, it might be too large for the SQL Server instance you're running, that kind of thing. So that's the idea, is we're bringing it all into a data lake or a data warehouse to try and consolidate things in a place that lets us integrate and join easily rather than copying data from source A to source B and source B to source A just so that we can mesh it together and get our insights.
All right, thank you. So,
all right. Okay, let's talk about Event Stream. And I won't spend as long as I like to on this one, which is the purpose. I wasn't planning to spend as long as I want to on this topic. I have other sessions about this topic at different times. But real time is something that you may or may not hit, but I think it's becoming more and more important for data engineers like myself to be ready to build fairly real time, if not, within a minute type processing jobs for analytics. You may not need a minute, 10 minutes, 15 minutes might be good. Either way, if you're starting to get under an hour, I think these streaming concepts and streaming platforms become really useful. In addition, things like Kafka that I'll explain to you are being used more and more to help microservices that make up a platform or application communicate with each other. And as an analytics developer, I can just tag on to that Kafka stream and pull out the information without having a separate feed of files or connecting to someone's database. So there's a lot of reasons why Kafka might be used even in batch scenarios. But what is Kafka? I want to make sure we have some high level view of this. So Kafka is a reliable place to stream events and keep them decoupled from the source, decoupled from the destination. And so I tend to talk about it in a little bit more generic way as a scalable message broker. The team at Confluent and a lot of the people that work on Apache Kafka, an open source platform, talk about it as a distributed log. And so if you read up on what they mean by distributed log, it's a really good way to think about it, but it might be a little newer to you than message broker, or you may even think of it as a message queue. Just don't go too far with that with that thought, because it's a little different than a lot of queuing systems. What's going to happen? Applications produce data to Kafka, quickly get an acknowledgement that Kafka has it. Kafka's not going to forget about that message. It'll be there for a determined period of time, 1 day, 7 days, could be forever, depending on how you set up your cluster. And then the consumers can come get it whenever they're ready, which is usually really quick. So ultimately, we've got this distributed log. We've got producers and consumers that there's a little bit of a contract. They know there's a topic that data is flowing through. Topic is really similar to the idea of a table. They know there's a data set coming, a stream going, and that there is a schema that data fits into. They know that Kafka is going to keep track of it, so they don't have to stress as much about storing the data forever, or at least for whatever time frame Kafka set up for. Kafka is very low latency. The data is going to flow through it really quickly. and it's highly scalable. So we can keep adding nodes to the cluster, keep scaling up our managed version if we've got that as our business needs change. So what we're doing with the Stack Overflow data as an example, we got more than two, but let's just say we've got two inputs. We've got post data coming in and user data coming in at the top of the diagram I'm showing. We've got Kafka or Event Hubs as another tool that works really well within Azure for really the same benefits that I've talked about already. We've got that data flowing into this middle layer of Kafka, and then we've got consumers like our data lake processes, our real-time report that might be separate from the data lake because it really does need to cut out as much extra steps along the way and get that data to our report real time. And then we might have a user dashboard that's part of our application that's just showing kind of here's the latest, view count, number of things you viewed today. You need to see that right away, not wait for our data lake to do a bunch of processing to clean it up for you. So all these things can communicate through one system without having to think too much about who's producing this, who's consuming this. As long as the schema stays the same once they agree upon it, Kafka can handle all that middle level stuff. So Spark Structured Stream is a way to take the concepts I showed you really briefly with Spark in our first example and apply those to streaming data. And the way you want to think about it is that we've got a continuously updating table in the background, and we're just going to treat it like it's a table of data. The main difference is that we know we've already produced some of this data out. We've already read some data and sent it out the other side to the sink. So we need to make sure we think about that as we do our additional processing. We don't want to just keep appending the same data unless we've already decided that's the right way to do it. Try and cover that just a bit as we get to the end of this. So if you noticed in the earlier example, we did spark.read, and I think I did .parquet. You could also do .format parquet to say which type of data I'm reading. When we're in streaming mode, we're going to do spark.read stream. That's the big difference. And then the options that are hidden in this consumer config variable, the options are going to be quite a bit different for Kafka because I need to authenticate, tell it where to go get that data, where my Kafka cluster lives. A lot more information than just a Azure Storage path like we used before. When it comes time to write, I go from df.write, data frame write, to write stream, and I have options and things again. I also have this checkpoint. So the checkpoint keeps track of what have I already read off of Kafka and kind of how far have I gone with writing this data to the destination. So that checkpoint's really important. You need to put that probably in your data lake storage, some kind of redundant storage. And you may tweak that slightly depending on performance, but usually data lake storage works just fine there. You have some output mode options. Typically, you're going to just append new records. You're expecting everything coming in is like a new event that you want to keep forever, at least in your raw layer of your data lake. And you'll just keep appending each event as a new thing that happened. Maybe that thing that happened is an update to an earlier set of information, but we kind of just keep appending them into a log typically. If I'm going to do aggregations and try and count like, I don't know, average views for the last 5 minutes, I might do a complete output mode where I say recalculate everything every 5 minutes and give me that snapshot each time. Output everything each time. So I can just filter on the output time and see it. Otherwise append or possibly update in some scenarios or ways that you can output the data. And then the benefits really, we can reuse our Spark batch code. So if I built some functions earlier about transformations on Spark, usually those will work just fine in streaming as well without changing anything. The read and the write are going to change a little bit. We just looked at that. Transformations in the middle can usually be the same. I'm going to rely on a lot of integrations to different source and sinks when I'm building out a data platform. And a lot of those have been built for Spark, both in batch mode and in streaming mode. And then you don't have to use Kafka or Event Hubs. You could use Delta files. There's some other integrations you can choose from. So don't feel like if you don't have Kafka or Event Hubs, you can't use Spark streaming. I bring that up because Confluent has some really good tools when working with Kafka, but you can't use them with some other sources and sinks. If Kafka is not a piece of the puzzle, they don't usually work. So Spark, you can do it completely without Kafka. All right, let's walk through this code relatively quickly, I think, to make sure we don't hold you all longer than you want to be here. And then I can come back to it with questions or see where the questions lie. So here I am in my scenario here is that I've got these monthly files that I loaded first. I didn't really tell you this earlier, but those are monthly files. They're not daily. And so I did this ingestion in my first scenario, but I don't have any data for August yet. And so what I could do is have something that's running regularly that posts all of the new Stack Overflow posts, new users, post those to my Kafka. my message broker, right, where I'm going to get the data from. And I can basically count on those to get me up to date. And so I'm going to stream those in throughout the month and write those down to data lake storage and possibly do some transformation as we go. We may not see this one work live. I'll save hitting the play button here because I think that cluster fell asleep on me. But let's look at the code that I ran earlier, and you'll see there's just a little bit of output with it that you'll be able to see. So again, I do some imports. I set up my paths that I might need. I set up a checkpoint path and a destination path. All of these are within my data lake. Nothing too crazy there. I'm going to, again, use my logging utilities. That's really important. Like I said, set up my logging with start logging. So some of this starts to look the same in every notebook. And we just take advantage of these utility notebooks to reduce how much we see code that looks identical across every notebook. Now in Spark, this snippet here is how you would define a schema. And so if you're messaging data to Kafka as JSON, you'll need to define a schema to read it back out and get it into a form that's going to be easy to save and parse and do anything with. And so here I've got a schema defined that I worked out over time. I basically kept it all as one big set of text and printed it until I could see what was going on and worked out the schema once. And it's okay if new stuff gets added to the schema. It's okay if things come through as null. It'll still work in those environments, but you may need something that kind of checks if there's any new columns, just so you don't forget to take into account any new columns in your stream. So now we're down to the actual code, and we'll just kind of give a quick view here that we've got quite a few options that need to happen. And so if you are trying to connect to Confluent Cloud, this is a config I would recommend you use. We store our API key and our API secret in Key Vault. Azure Key Vault's where we'll normally store any secrets. We'll definitely not paste them plain text into our notebooks. That's not safe enough. And so MS Spark Utils lets us do that. This type of command will get you there. Demo KV is the name of a link service that is a Key Vault link service. So just keep that in mind. That's what's happening here. So with my host name, my port, my keys, and my topic of Stack Overflow post, I can call Spark read stream just like I showed you in the slides, format a Kafka, pass in all these options that once you know them, you just keep using them. You don't have to like understand them too deeply besides what I'm showing you to pass in. And from there, I've got data to read. Now, Kafka is interesting, Event Hubs as well. If you're using the Kafka API at least, is that it's a record that comes out. It's not just the raw data. There's a key involved. There's an offset, which is your position within all of the history of that distributed log we talk about. And so what we do is we select out the key and cast it to string, because that could be different data types besides string. We also grab what's called a value from the record. Call.value means there's something in this record called value, cast it as a string, and then run this from JSON function on it with that schema I showed you above. So we've just said, read this as a string, parse it out as JSON, and make it a column called JSON. Once I've done that, so that's kind of the thing that'll be very similar across any JSON streams you deal with. Once I've done that, it starts to look a lot like a Spark in a moment here. The other thing we might want to do is join the data to our user data. So we've got some posts coming in. If we're going to do something real time, we probably need a little more information on the user that made the post. And so I'm going to do this is not a stream. This is a batch read of whatever currently exists in my user table. I'm going to read in my new users, which have been updated very recently, probably throughout the day. I'm going to read in my monthly users, the ones I get that file once a month. I'm going to union them together with a Spark union statement. Pretty straightforward as long as the schemas match, which is why I renamed each field. I get that user set ready to go. And now I can call streaming data frame here, join to my batch data frame I constructed out of those two data sets. I give it a join condition. In this case, I'm saying grab the owner user ID column from my post data frame, take the user ID from all users data frame and join on that. I can specify whether it's a left join or an inner join. Do some logging, of course. I'm always going to log where I think it might be helpful in the future. And then finally, I start up that stream. And so I'm going to set this variable Q with my streaming query. And basically, I take my data frame. None of this has run yet. I didn't really cover that at the beginning, but Spark's a bit lazy. It's going to run everything when you trigger that final like write statement or final command that needs to do something with the data. Before that, I'm just building up this query that's going to get optimized under the covers and do the work for me once I kick it off. So by setting a trigger, setting a checkpoint like I showed you, picking a format, in this case, I'm doing Delta files, and giving it an output mode, I can start it right here. I do start, give it the path. And then I have a few options with how I handle my query. Just to make sure I save some money here, I've got it set to process everything that's available and then turn off right away. So if I wanted to schedule this every 15 minutes, let's say, I might actually leave the code exactly how it is right here. If I want it to be on continuously, I would pick a different option for the query, which I think is a wait termination, if I remember right. And it would just keep running and running until I stop the job at some point. So let's run all these cells, see if we're connected still and get some data. But that's really what's going on when we do streaming. This last piece here, I think I've already got data, so we'll cheat a little bit. It's going to show you what that output data ends up looking like. Hopefully the way I described it, you already kind of know what to expect, but basically what we're going to see is all of our fields from the post data that was streaming in. It's a fairly small subset with, I think I've actually forced some streaming of July data, so it's not going to be today's dates like you would expect in the real world, but it's going to join to a recent user from the API, and that's how we will build out our data set. And it looks like it stopped my Spark session, even though I got lots of, oh, yep, it stopped my Spark session despite my settings. I tried to keep it alive for you all. I think I just talked too long, might be the issue. So that's how the streaming data works. I can come back and answer questions, and it'll eventually start running for me too if anyone really needs to see that before we drop today. So with that, yeah, that's the presentation. What questions do we have out there?
Awesome. Really great. Let's take a look at over here. As far as questions, I know that we have plenty, so I need to just scroll back up here for a minute. We can get a sip out there. Sorry about that. All right, folks, remember, you have a question there, like, subscribe, definitely enter your question in the live chat. So who we have here? All right. Question from Mojo. Presumably, you could create the tables using SQL and not PySpark in Synapse?
Yes. So if you're going to pull into your data lake, you could use, there's a couple things that could be being asked. You could use Spark SQL to create tables. If you're really comfortable with SQL syntax, that might be easier for you than the way I do the save tables. You could use serverless SQL to create the tables. So you save the files with Spark, and then you create an external table in serverless SQL with that same storage location and query it that way. Now, if you do it, I didn't show this, I meant to show this. If you do it with PySpark the way I showed you within Synapse, save it as Parquet, I can go into serverless SQL and query that same database. It's going to be replicated behind the scenes really quickly. I can query that same raw data set automatically with serverless SQL without having to define the table again. So yeah, there's a few ways to do it. When you get to Delta, you still would need to create the table yourself anyway. So I definitely recommend trying to derive the schema and everything from what you do with PySpark or whichever thing you use to load it. Try and derive the schema and automatically generate those tables if you expect people to use serverless SQL at all.
All right, great tip right there. Next, that's a classic here. When should I use Spark over Synapse?
So let me switch the question a little bit. So let's say Spark over Synapse Pipelines. Here's what I'd say. If you have a team that is comfortable programming or wants to be comfortable with programming, writing code the way I showed you, you got a good feel for kind of what goes into that for Spark. I really like Spark because you can do pretty much anything you would want to do. It's super customizable because you're writing the code yourself, and you can do reusable functions and modules really easily. And when it comes time to do your code reviews, you're going to be used to looking at the code, and you'll see the differences in the code a lot easier than if you are doing pipelines, which you don't really have a tool. As far as I know, at least, you don't have a tool to show you what was just changed really cleanly to know what happened. So when you get into the more like long-term production maintenance of this with a team of people, I really like Spark for that. The number one reason though I go Spark over pipelines is because I can hire people that have been doing big data for a very long time with Apache Spark, and they'll come in and know how to get started. They'll have to look up just a couple of functions specific to Synapse, and they're good to go. The alternative, though, if you're going to hire a bunch of people that already know Synapse Pipelines, then you might have more reason to do that than I do. So that's my take on it. I do like Synapse Pipelines for orchestration, though, to run the different Spark notebooks, make sure that, we run 3 or 4 notebooks in parallel because they aren't dependent on each other. Once they're all done successfully, we kick off the next thing. I still use Synapse Pipelines for that a lot. And then for special use cases, like I showed, where it's just easier for me to connect to SQL Server and make it really dynamic with pipelines over Spark in this case.
All right. Great answer there. And
it's okay to disagree, but that's my answer, and it has been for a while. So
yeah, I mean, there is no context about the approach. First of all, as you said, what is the skill set of the team you have? You also outline why you prefer one path than the other path. Absolutely. And I don't think anyone can contest about flexibility, that having the ability to code versus no code approach there is there. All right, so we also have Mojo. Where do we head for a bit more content to flesh out the many knowledge gaps?
Can I share my screen real quick?
All right, sure. That's what I was gonna.
All right, so
let's get that
number one that I can help with is go check out dustinvannoy.com, which has a link to quite a few of my YouTube videos and written posts. You can kind of pick what you like.
I'm looking at Google right now. Sorry.
Yeah, you are. So the other thing you can do, if you go to github.com data kickstart, I don't know, Adriano did an awesome job of getting all the links in the thing, so maybe this is there. If you go to github.com data kickstart, this is my code. I know it's probably hard to read with this browser. Synapse examples is one place, Databricks notebooks. I'm kind of working on another place for data ingestion examples. I don't think I've populated that yet, but soon I will. And I'll have similar examples to what I did today. So those are some places to find code, because I do like to go grab the code and be able to use it. I have a video about doing the Synapse pipelines. I think I did. Oh, no, I haven't posted that one on YouTube yet. I'll do that eventually. But I have some stuff about speeding up Spark and doing some really specific things with Spark on YouTube. And then obviously meetups like this and checking out other sessions at conferences and things are really good ways to learn more. So if you like a very focused course approach, there's some paid sites that have pretty good stuff out there. I don't have the best recommendations on like free or really cheap Synapse Spark, or even just Spark tutorials, but that's why I do YouTube, to try and help you get it for free in short bits. And then if anyone's dying to see that streaming job, since I happen to share my screen, this is what it looks like at the end. Way at the right, we're going to see it join to user data. Hopefully you could picture that, but just in case someone was out there wondering, there it is. Okay.
Excellent. One more thing from Kriba. Why would I insert to a data lake from SQL Server? Would I not use SQL Database, manage instance of SQL DB? Did I ask that? I don't.
Yeah, we covered that earlier. And the short answer was, we want to get a bunch of data together that's not already in SQL Server. And so we might pull that all into a data lake that's super flexible for all data types. And if there's a need to query it with SQL Server still, you can keep that going. Or you might build a data warehouse downstream of the data lake, do a bunch of processing in your data lake, and then have a SQL Server data warehouse or special instance if you need some really quick response SQL-based reporting.
All right. With that, all I can say is Mojo put it all in 2 words. Brilliant presentation.
Appreciate it.
Really appreciate it as well. Dustin, great presentation. Folks, let's take a look here real quick to the wheel of names. Let's see. And 2 seconds. Let me load the names here. And who is the winner? We will be doing 2 winners today. All right, folks. Where are we? second. All right, folks. Let me know. You can see here. We're gonna spin it to win it. How about that? And what do we have out there to win? This is the book raffle for the Azure Synapse Analytics cookbook from Packet. Thank you, Packet, for contributing there. And let's take a look at it. So here we are. I just placed it. This is alphabetically listed the names. And now let's do some shuffling. All right. Cross your fingers and let's click it to spin it. See, number one here is, the winner is for the Azure Synapse Analytics cookbook. It's Vinay. Congratulations, Vinay. We'll be contacting you there. All right, we still have an opportunity for another book. So, not all is lost, folks. Let's give it a try here. And the winner is Sakasra. We will be contacting you. And for today, that's it, folks. And but it's not finished. August, the Microsoft Data and AI celebrates its 10th year, and the celebration is Azure making it Azure Synapse Analytics Month. So on the 30th, we have another presentation, and we'll be announcing it in the coming days. So remember, subscribe, like, share the channel, join the meetup group so you can also be informed when there is a new presentation coming up. And please drop a comment, very important, to the success and sharing the information with everyone out there. And with that, also remember, check out the San Diego user group with Dustin Vannoy and his guests as well. Fantastic place to learn too. Just to add it over there. All right, Dustin, thank you very much, folks. Thank you all. Really appreciate that. And I'll see you all next time. Have a great one. Thank you. And ba-da-bum-bum.